So my project is on the non-parametric density estimation with the Dirchlet process. And the data that I use is called a date fruit dataset. So we're only interested in one variable, which is called area. That is the 2D area of an image, and we're interested in estimating its density function. So we plot it, and it looks like this weird and fancy shape. Basically, it's hard to characterize it by any particular um, parametric distribution family, and we want to introduce a mixture model to capture this density, and this is the primary motive for using a Dirichlet process as our prior. So what I will do in this project is to basically compare the traditional estimation method with the non-parametric estimation method, and to show that how the Dirichlet process could be a very helpful prior in the mixture model and why that model is superior in terms of estimating this type of densities. So this is the step that I used to conduct the traditional uh, data model density. There's not too much interesting going on here. Basically, we use the things that we learned in class, and we generate some posterior predictive samples, and we plot the density, and it looks like none of these traditional estimation method can very accurately estimate the density function because of the weird shape of the original data. And this is why we want to introduce the Dirichlet process as a prior for a mixture model. So the Dirichlet process is a really popular prior, a stochastic process used for non-parametric models of data. The idea is really just to fit a mixture model where each observation could belong to one of many unknown latent clusters or latent classes. And with that classification, each latent class would have a different distribution, and the whole data distribution would be essentially a mixture of those distributions by their weights. So if we want to get a more accurate understanding of what this looks like, we can look at the result page here. What this means is that at the end of the day, the model is able to find two main models, one with about 0.3 weight and another with about 0.7 weight. The idea is that if you look at the data distribution, it makes sense because it looks like it's a composition or a mixture of two normal distributions. And the results from the DP estimation, as you can see, is much more satisfactory, much more closer to the original distribution. And that's what I have done in this project.